Welcome, beginner game developers, to an essential guide on the Observer game design pattern. This pattern is a fundamental concept in software engineering, particularly useful in game development for creating flexible and maintainable systems. Design patterns are proven solutions to common software design problems, offering reusable blueprints for recurring challenges. The Observer pattern, specifically, helps manage dependencies between objects efficiently, ensuring that changes in one object can automatically trigger updates in others without tight coupling. At its core, the observer pattern establishes a one-to-many relationship. This means a single subject object can notify multiple observers about its state changes. It's a powerful way to decouple components in your game. Think of it like subscribing to a YouTube channel. The channel is the subject, and you, the subscriber, are an observer. This analogy perfectly illustrates the core concept of how one entity broadcasts information to many interested parties. When the channel uploads a new video, all subscribers receive a notification. Similarly, in the observer pattern, when the subject state changes, all registered observers are automatically updated, ensuring they react appropriately to the new information. The subject maintains a list of all its observers and is responsible for notifying them when its internal state changes. Conversely, observers register with the subject to indicate their interest in receiving these updates, and they can also unregister when they no longer need notifications. Now, let's dive into implementing this pattern in C# using Visual Studio. We'll start by defining the necessary interfaces that will form the backbone of our observer pattern implementation. First, we define our iSubject interface. This interface will include methods for register observer, allowing observers to subscribe, unregister observer, for observers to unsubscribe, and notify observers, which the subject will call to inform all registered observers of a state change. These methods are crucial for managing the list of observers. Next, we create the iObserver interface. This interface is simpler, containing just an update method. This update method is what the subject will call on each observer to send notifications, allowing each observer to react to the state change in its own way. Our concrete subject class will then implement the iSubject interface. It will manage a private list of iObserver instances. This class will contain the actual logic for adding, removing, and iterating through observers to call their update method whenever a relevant state change occurs within the subject. The notify observers method is crucial within the subject class. It iterates through all registered observers in its list and calls their respective update method. This ensures that every interested party is informed about the state change, allowing them to perform their specific actions. Then, we create a concrete observer class that implements iObserver. This class will define how it reacts to updates received from the subject. For demonstration purposes, its update method might simply print a message to the console, but in a real application, it would perform more complex logic based on the notification. This setup ensures loose coupling, a key benefit of the observer pattern. The subject doesn't need to know the specific types or implementations of its observers. It only interacts with them through the iObserver interface. This makes the system highly flexible and easy to extend or modify. Now, let's see this in action within Unity 3D, applying the observer pattern to a player's health system. This practical example will demonstrate how these abstract concepts translate into a functional game mechanic, enhancing modularity and responsiveness. In this scenario, our player's health will be the subject, as it's the entity whose state changes and needs to be monitored. The UI health bar will act as the observer, as it needs to visually reflect any changes in the player's health. We'll create a player health script that implements our iSubject interface. This script will manage the player's health value, handle damage or healing, and crucially, notify all registered observers whenever the health changes. This centralizes health management and notification. The health bar UI script will implement iObserver. Its update method will be responsible for receiving notifications from the player health subject and then updating its visual representation, such as adjusting the fill amount of a health bar image to accurately reflect the current health value. In the Unity editor, we'll link the health bar UI observer to the player health subject. This is typically done by dragging and dropping the health bar UI script instance into a public field on the player health script within the inspector panel, establishing the connection between them. When the game runs and the player takes damage, The player health subject detects this change. It then automatically notifies the health bar UI observer, triggering its update method to reflect the new health status. This happens seamlessly in real time. This automatic update ensures the UI always reflects the current game state without any direct, tight coupling between the player's health logic and the UI display logic. It's a clean and efficient way to keep different parts of your game synchronized. The observer pattern offers significant benefits, including loose coupling, which makes your code more flexible, easier to maintain, and less prone to errors when changes are introduced. This is a cornerstone of good software design. It also promotes reusability, as observers can be easily swapped or used with different subjects, and new observers can be added without modifying existing subject code. This modularity saves development time and effort. For beginners, understanding this pattern is a crucial stepping stone to building scalable and robust game systems. It teaches you how to manage complex interactions in a structured and efficient manner, preparing you for more advanced game development challenges. Keep practicing these concepts, experiment with different scenarios, and you'll master game design patterns in no time. Happy coding! And remember that good design patterns are the foundation of great games.